Hello friends, welcome to Chemala's Automation. In this video, we will learn about basic programming instructions. We will start with bit logics. Bit logics means like normally open, normally close, set, reset, flip-flop. We already learned about hardware configuration. Once you've done the hardware configuration, open the OB1 organization block. In organization block, we will start to develop programming. Open the semantic manager window. In semantic management window, you can see OB1. Click on OB1. In OB1, on left side you can see instructions, bit logics, comparators, converters, counters, instructions. In Siemens we are calling network means one line of program, like one line of code. In Allen Bradley PLC we can call rungs, one line of program called rungs. In Siemens we are calling this one is network, one line of program. So that means we can take network 1, network 2, network 3, network 4. We can take number of networks, depends on our program. Now we will start with bit logics. Normally open and normally close. What is difference between normally open and normally close? In normally open, when I press the button, the output will be energized. But in NC, normally closed condition, when I press the button, the output will be de-energized. We will see in the program this both normally open and normally close. I'm adding normally open and output. This is my normally open and output. Now I need to give address, but I don't know what is my address. My module may start with address from 0 or 1 or 2 or 3. To check this address, go to hardware configuration. In the hardware configuration, you can see my digital input starts from 0, but my digital output starts from 4. But I want to change my input address and output address starts from 0. To change your module address to 0, click on digital input IO module and go to address settings, and you can see here there is a system default. By system default, my module input module address starts from 0, but I want to start with different address. Like if you want to start with 1 or 2 or 3, you can change by clicking on system default, deselect system default, then change your desired input address. I want to keep my digital input addresses from 0. I want to change my digital output address 4 to 0. Then click on digital output module, go to address option on the menu, deselect system default and change start from where you want to start your address. I want to start from 0. So by default it was 4. I want to change to 0. Change to 0 and then click on OK. Then download this configuration to your module. Now go to organization block to assign your input address and output address. Now I'm giving my input address is I0.0 and my output address is Q0.0. Now I want to give the name to my input address and output address. To give the name for the input address, right click on input and select edit symbol. Here you can give the symbol name and comment. Symbol name is what is that input address. Like for example, my input address is switch. In the comment you can write the switch is what is the purpose of that switch. This is when switch is on, what is the condition. You can write in the comments. I given my input comment is switch, my output comment is motor. Now I want to test the program. Download this program by pressing download button on the menu. Once downloading is finished, click on monitor symbol. There is a monitor symbol on the menu. Click on monitor. Now my CPU is in stop mode. Go to simulation window. Change your CPU to run and program mode. In simulation window, I need to add my input variable and output variable to trigger. So this is simulation to switch on or to turn on my input variable. Click on input variable and select your address. It starts from I0.0, so IB0. Then select output variable, that is also starts from 0, so select IB0. Now program is in run mode and monitor mode, so we can monitor the program. This program is just normally open one contact and output. When my normally open contact is on, the output will be on. Initially my normally open contact output is off. That means see, the motor is off. When my turn on, switch, the motor will be on. So this is normally open contact. Now we will take two normally open contacts in series with output. Now two normally open contacts are in series. If I triggered I0.0 but my output is not on. When I trigger I0.1, when both normally open contacts are on, my output is on. This is in series. Now we will add two parallel switches. That means any one switch is on, my output will be on. To add parallel network, click on Open Branch from the menu, add normally open contact and give the name for the address. And then click on Close Branch. Now download this program to CPU. Then click on Monitor. To turn on this input, go to Simulation window and select your input address. In parallel condition, if you toggle any one input, the output will be on. If I toggle I0.0, the output is on. Or if my I0.2 is toggle, my output is on. In parallel condition, if any one input is on, my output will be on. Now we will see normally closed contact. Add normally open contact to network and output. Download this program to CPU and click on Monitor. See here, I didn't turn on or I didn't switch my input, but my output is on. This means initially my output is on. When I turn on my input, the output is off. It's exactly opposite to normally open contact. Let's take one normally open contact and one normally closed contact with output. My address I0.0 is already turned on because that is normally closed. My second contact is normally open. If I toggle that one, the output will be on. In this way, you can use in the program normally open and normally close. Thank you for watching. In next video, we will continue bit logics.